So here we can see an example of creating parameters and establishing relationships between geometric parameters. And they're referred to here as a driving and driven parameter. The driving parameter being the first original parameter, and the driven parameter being the subsequent parameter that is being controlled by the primary driving parameter. So here we have an example of a sketched rectangle with a width S2 and a height S1, and we're going to create an expression which relates the width to the height, where the width is always twice the height. So the process is to dimension the sketch height and width, create the design parameter S1 here, and S1 will become our driving parameter. So we go to the sketch, we go to the dimension for the height, which is V2 here. We click on this open box in order to populate it with the blue D. This then exposes it as an input parameter, geometric input parameter, and it's listed in the parameter manager here as S1 and the value associated with S1. So S1 is now our driving parameter. So we know that the H, as far as H1, which is a subsequent part of the format of the internal name for the parameter, indicates the horizontal dimension, and the corresponding V in V2 is associated with the vertical dimension of the vertical parameter. And from the parameter dimension assignments, we note that xy plane.v2, V2 is the vertical value, is equal to the S1 input parameter. So if we know the internal parameter name, xy plane.h1, we can then assign that to the external parameter name, in this case S1, and we can say that xy plane.h1 is equal to 2 times at S1. So this ensures that it's always twice the value of the original V2 value parameter. So at this point we can verify the value or the relationship by simply changing one of the changing the driving parameter, and then refreshing the geometry by hitting F5 in the geometry window, and that will regenerate the geometry based on a change to the driving parameter, and will update the associated driven parameters, and you'll see the geometry change in the GUI. Alternatively, what we can do is we can visit the check tab, and this will list out the input parameters and the driving and driven parameters, and we can see the outputs here. The driving parameter might be a value of 35 millimeters, and the driven parameter is 2 times that of 70, so we can validate that the expression has been defined correctly with this check tab window. The check tab window is split into 2 parts, the first part being the parameter dimension assignments. As in the previous slide, we can see here the driving and the driven parameters and the values associated with them, and also the design parameter assignments as well, that are listed in the lower part of this check window. So in the above case, you can see that our parameter S1 is assigned a value of 35. Similarly, the driven parameter evaluates to 70, and since we wish to drive horizontal value to the value of 2 times S1, we're validating here that this is indeed correct.